All right, this is part 5, learning the Python basics. Welcome. Not gonna lie, it's hard to be consistent, but it's important that we be consistent, right? Because that's how you learn is consistency. So let's go ahead and get started. Go ahead and share my screen. There we go.
In this tutorial, we're going to look at a few useful functions for working with numbers. Let's start by defining a variable like x and set it to 2.9. Now, to round this number, we can use the built-in round function.
All right, so we're gonna learn the built-in round function. Here we go.
We call the round function, give it x, and then print the result. Let's run this program. So we get 3.
All right, so let's go ahead and do that. X equals 2.9. I'll print that. Right. Round x run that. Okay. Alrighty.
We have another useful built-in function called ABS, which is short for absolute. And this is the absolute function that we have in math. We give it a value, and it always returns the positive representation of that value, even if that value is negative. Here's an example. Let's call the ABS function and give it negative 2.9. When we run this program, we're going to see 2.9 on the terminal. So let's go ahead. There you go. So absolute always returns a positive number.
All right, so go ahead, type in print ABS for absolute. Negative 2.9. Run function. All right.
Now, technically, in Python, we have a handful of built-in functions for performing mathematical operations. If you want to write a program that involves complex mathematical calculations, you need to import the math module. A module in Python is a separate file with some reusable code. We use these modules to organize our code into different files. As a metaphor, think of a supermarket. When you go to a supermarket, you see different sections for fruits and vegetables, cleaning products, junk food, and so on. Each section in a supermarket is like a module in Python. So in Python, we have this math module, which contains a bunch of reusable functions for performing mathematical calculations. So let me show you how to use this module. On the top, we type import math, all in lowercase. With this, we can import the math module. Now math is an object, like a string, so we can access its functions, or more accurately, its methods, using the dot operator. So if you type math dot, look, these are all the mathematical functions available in this module.
All right, so let's go ahead on the first line. Import math. And the third line, I'm going to type in math. Dot. Oh, that's cool. All right.
For example, we can call the ceil method to get the ceiling of a number. So if we pass 2.9 here, and then print the result, we should see 3. Let me delete all this other code here. All right.
All right, so let's see here. And go. Let's see. Print. Math dot seal 2.9. Run that. Oh, okay. Cool.
Right, let's run this program. There you go. So we get 3. Another useful method is the floor method. So let's give that a try. Floor of 2.9. What do you think we're going to get? We get 2. Now, there's so many functions built in this module, and we don't really have time to go through all of them. But let me show you how you can learn about them on your own. Open up your browser and search for Python 3 Math module. Make sure to add the version, Python 3. Because the math module in Python 2 is slightly different from the math module in Python 3. So Python 3 math module. Now here, you can see the documentation for this module. Let's go. Let's have a look. If you scroll down, you can see the list of all the functions and their explanation. So as an exercise, I encourage you to spend 5 minutes, have a quick look at this documentation, see what functions are there for you in case you need them.
Okay, in the sake of time, we're not going to review all those functions, but at your leisure, go ahead and take a look at some of those functions.
My life would be completely different without the Google Career Certificate. I lost my job due to COVID.
In this tutorial, I'm going to talk to you guys about if statements in Python. If statements are extremely important in programming, and they allow us to build programs that can make decisions based on some conditions. So if some condition is true, we're going to do certain things. Otherwise, we're going to do other things. Here's an example. Over here, I've got this text file with a bunch of rules for our program. If it's a hot day, perhaps we want to tell the user, it's a hot day, so make sure to drink plenty of water. Otherwise, if it's cold, so here's another condition. If this condition is true, we're going to tell the user, it's a cold day, so wear warm clothes. And otherwise, if it's neither hot or cold, we want to tell the user, it's a lovely day. So let me show you how to write a program that simulates these rules. So back to our program here, we start by defining a Boolean variable, is underline hot. We set this to true. Next, we add an if statement. So if, here we need to add a condition. In this case, we're going to use our Boolean variable. So is underline hot. Now, if this if value is to true, then we're going to do certain things. In this case, we want to tell the user, hey, it's a hot day, drink plenty of water. So back to our program. After our condition, we add a colon. Now, note that when I press enter, PyCharm automatically indents our cursor. Now, any code that we write here will be executed if this condition is true. Otherwise, it will be ignored. Here's an example. Let's write a print statement. Here I'm going to use double quotes because I want to use an apostrophe in our string. So it's a hot day. Now let's press enter. You can see the cursor is still indented. That means we can write more code that will be executed if this condition is true. In this case, let's say we don't want to write any extra code. So to terminate this block, we need to press Shift and Tab. Now the cursor is at the beginning of the line. So let's write a print statement with a message like, enjoy your day. Now, when we run this program, because this condition is true, we're going to say this message followed by this second message. Take a look. So run. There you go. It's a hot day. Enjoy your day. But if I go over here and change this Boolean value to false and run the program again, our first message disappears and we only see the second message, enjoy your day. So this is how if statements work. Now back here, we can add another print statement. Let's say, drink plenty of water. Now, because this print statement is also indented, it will be executed if this condition is true. So I'm going to revert is hot to true and run the program one more time. There you go. So it's a hot day, drink plenty of water, and enjoy your day. All right, now let's add a second rule here. If it's hot, we're going to execute these 2 lines. Otherwise, if it's not hot, we want to print a different message. So here, We remove the indentation and type else colon. Now, when we press enter, once again, our cursor is indented. So the code that we write here will be executed if this condition is not true. So here we can print, it's a cold day, print, wear warm clothes. Now let's run our program one more time. So we get the messages about a hot day followed by enjoy your day. We don't see any messages about a cold day. Now, if we go back here on the top and change this Boolean value to false and run our program, we see different set of messages. It's a cold day, wear warm clothes, and enjoy your day. But there's a problem with our program. If it's not hot, it doesn't necessarily mean that it's cold. Maybe it's a lovely day. So the absence of heat doesn't mean it's cold. Back to our conditions. Here on line 4, we have this rule that says if it's a cold day, then print these messages. Otherwise, if it's neither hot or cold, then say it's a lovely day. So to implement this rule, we need to go back to app.py and define another variable. So let's say is underline cold. We set this to true. Now here we need to add a second condition. So after our first if statement, we can use an elif statement to define a second condition. Here's how it works. So elif, which is short for else if or otherwise if.
All right, so that's else if for elif. All right.
Now here we add another condition. So is cold. So if it's cold, we want to execute these two lines. So let's cut these from here and move them under our second condition. And finally, if none of these conditions are true, you want to print a different message. It's a lovely day. So right now, is hot is false, is cold is true. So when we run this program, Python interpreter is going to execute the first if statement. In this case, because our condition is false, these two lines will be ignored. Then Python interpreter will look at line 7. It will evaluate this condition. In this case, is cold is true. So we're going to see these two messages on the terminal. Now, in this case, because one of these conditions was true, this else statement will be ignored. So we are not going to see this message. And finally, as before, we're always going to see this message. So let's run our program. There you go. It's a cold day. Wear warm clothes and enjoy your day. Now, back to the top. If we change is cold to false, it's neither hot nor cold. So it's going to be a lovely day. Let's run the program. And here you go. It's a lovely day. Enjoy your day. So this is the basic of using if statements. As you can see, they're very useful in programming. And with these, we can build all kinds of rules into our programs. Okay, here's an exercise for you. Imagine the price of a house is $1 million. Now, if the buyer has good credit, they need to put down 10% of the price of this property. Otherwise, they need to put down 20%. Write a program with these rules and display the down payment required for a buyer with good credit. You will see my solution next.
All right, so take about 30 seconds just to kind of contemplate on this. And then due to time, though, we're going to continue. So the price of a house is $1 million. If a buyer has good credit, they need to put down 10%. Otherwise, they need to put down 20%. Print the down payment. So this is the if statements. Let's go.
All right, let's define a variable for the price of this house. So price, we set this to 1 million. So 1 with 6 zeros.
All right, so let's do that. So I'm going to start with the value of the home. Three, 4, 5, 6 zeros. All right. Sounds like a home in California. All right.
Next, we need a variable to tell if this buyer has good credit. so has good credit. And we set this to true.
All right, so the buyer does have good credit. Good credit equals true, right?
Now we need an if statement. So if has good credit is true, colon, here we need to calculate the down payment. So down underline payment should be equal to 0.1 times the price. That is 10% of the price of this property.
All right, so line 4, type of if statement. Yes, good credit. Payment equals 10% or 1 asterisk multiplication price. All right.
Otherwise, colon, the down payment should be 0.2 times price.
Okay. Otherwise, else statement, payment equals 0.2 price. All right.
Finally, we remove the indentation and print. Here we can use a formatted string. First, we add a label, down payment, colon, and right after that, we add a placeholder or a hole for our down payment variable. So,
All right, so print function payment space. All right.
curly braces, down payment. Let's
Payment.
run this program. So, down payment for a buyer with good credit is $100,000.
That's it. All right, so let's run this. So the down payment of $1 million home would be a whopping $100,000.
Now, let's improve this by adding a dollar sign before this number. So, back to our formatted string, just before the curly brace, I'm going to add a dollar sign. Let's run this one more time.
So go ahead, add your dollar sign, run the file again, and you should have a dollar sign.
That is better. In this tutorial, I'm going to talk to you guys about the logical operators in Python. We use these operators in situations where we have multiple conditions. Here's an example. Let's say we're building an application for processing loans. If an applicant has high income and good credit, then they're eligible for loan. So in this example, we have two conditions. One is having high income and the other is having good credit. So if both these conditions are true, then the applicant is eligible for loan. So this is where we use the logical AND operator. We use this operator to combine two conditions. And by the way, this is not specific to Python programming language. Pretty much any programming language that supports if statements also supports the logical operators. So back to our program, let's define two variables. Has high income. We set this to true. And another one has good credit. We also set this to true. Now our if statement. If has high income is true and has good credit is also true, then we're going to print eligible for loan. So this is where we're using the AND operator. So if both these conditions are true, then this message will be printed. If one of them is false, we're not going to see this message. Let's try this out. So I'm going to run this program. So we see eligible for loan. But if we change either of these conditions to false and run the program again, look, the message disappeared. So this is the logical AND operator. We also have the logical OR, and we use that in situations where we want to do certain things if at least one of the conditions is true. For example, let's change the rule for this program such that if the applicant has high income or good credit, then they're eligible for loan. So if either or both these conditions are true, then the applicant is eligible. Now, back to our program, we can implement this rule by using the logical OR operator. So we simply replace AND with OR. Now, when we run this program, we're going to see this message because at least one of our conditions is true. Let's take a look. So the applicant is eligible for loan because they have good credit. If we change this to false, but set the other condition to true and run the program, we still see the same result. But if both these conditions are false, then we're not going to see this message anymore. So this is the difference between these operators. With the logical AND operator, both conditions should be true. With the logical OR operator, at least one condition should be true. We also have another logical operator called NOT, and that basically inverses any Boolean value we give it. If we give it a true Boolean value, it converts it to false. For example, let's make up a new rule. If applicant has good credit and doesn't have a criminal record, then they're eligible for a loan. Let me show you how to implement this. So we go back to our program. In this example, we don't need the first variable, so let's delete that. Let's set this variable to true. We also define another variable like has criminal record. And we set this to false. Now, we want to check to see if this applicant has good credit and not a criminal record. This is where we use the not operator. So if they have good credit and not criminal record. So in this example, has criminal record is set to false. When we use the not operator, this basically gets changed to true. So we'll have two conditions that are true. Here's one and here's another one. So our applicant is eligible for loan. And when we run this program, we see this familiar message. However, if an applicant has criminal record, so let's change this to true. Now, when we run this program, we can see our applicant is not eligible because when we apply the not operator on this variable, we'll get false. So true changes to false. And we'll end up with two conditions. One is true and the other is false. So the result is false. And that's why this message is not printed. So this is all about the logical operators in Python. In this tutorial, I'm going to talk to you guys about the comparison operators in Python. We use comparison operators in situations where we want to compare a variable with a value. For example, if temperature is greater than 30, then we want to print it's a hot day. Otherwise, if it's less than 10, it's a cold day. Otherwise, it's neither hot nor cold. And by the way, here I'm talking about Celsius, not Fahrenheit. So to build these rules into our program, we need to use comparison operators. Back to app.py. I'll define this temperature variable. Let's write an if statement. If temperature, now we want to check to see if this is greater than 30. So we use the greater than operator. If this is greater than 30, we want to print it's a hot day. Otherwise, let's just print it's not a hot day. Now, when we run this program, we're going to see the second message because 30 is not greater than 30. So our first condition evaluates to false. Let's verify that. So run, it's not a hot day. Okay. Now, if we change the temperature to 35, and run this again, we're going to see a different message. It's a hot day. So this is where we use comparison operators. Now, what we have here, as you know, is an expression because it's a piece of code that produces a value. So more accurately, this is a Boolean expression. So this is the greater than operator. We also have greater than or equal to. We have less than or equal to. Here's the equality operator. So if the temperature equals to 30, then we can say it's a hot day. Note that this is different from the assignment operator that has only one equal sign. You can see if we use one equal sign here, we immediately get this red underline because this is simply an assignment statement. We're changing the value of the temperature. We're setting the value of the temperature variable to 30. We are not comparing it with something else. So we don't have a Boolean expression. We are not producing a Boolean value. Okay? So our equality operator has two equal signs. And finally, we have not equal, which is an exclamation followed by an equal sign. Now, here's an exercise for you. You've probably seen that when you fill out a form online, sometimes the input fields have validation messages. For example, let's say we have an input field for the user to enter their name. Now, if the name is less than 3 characters long, we want to display a validation error like name must be at least 3 characters. Otherwise, if the name is more than 50 characters long, then we want to display a different validation error, like name can be a maximum of 50 characters. Otherwise, if the name is between 3 and 50 characters, then we just want to tell the user that name looks good. So go ahead and write a program to implement these rules.
All right. Want to see the solution?
All right, let's define a variable called name and set it to, let's say, J. So we're assuming this is what the user types into an input field.
All right. So let's go ahead and clear. Type in name. J. Double quotes.
Now we want to get the number of characters in this string. So we use the len function, right? Len of name. When we print this, we get 1, right? You have seen this before.
All right. So I'm going to go print in name. Run that. Okay.
Now here we want to use an if statement. So if len of name is less than 3, then we want to print name must be at least 3 characters.
All right. So len. Print len name is, let's see, less than 3, colon. All right. So print name must be at least 3 characters. Okay.
Now here we need a second condition to check.
All right, so let's go back. Okay, print name. If my name is less than 3, print name.
The upper limit. So L if len of name is greater than 50, then we want to print a different message. Name must be.
All right, so let's type Elif in name. And then 50. And print. It must be, all right.
A maximum of 50 characters.
Okay, it must be maximum of 50 characters.
Okay.
All right.
And otherwise, so else, if none of these conditions is true, that means the name looks good. So print name looks good.
Else. Print name looks good.
Let's run our program. So in this case, we get this message because our name is too short. Now, if you go back here and type something really, really long, and then run our program, we're going to see a different message. Name must be a maximum of 50 characters. And finally, if we type a proper name here, like John Smith, and run our program, we get name looks good.
All right, so let's go ahead. All right, type in John Smith. Okay. All right, so we're going to go ahead and pause there. Great work. Great work. Keep up the great work. And going to take off, and we will see you on Friday. Have a wonderful weekend. And on that note, have a good one.